Okay, well, good afternoon. Let's get started. This is the NASFA Learning Series presentation, Capturing Existing Conditions to Use in BIM. My name is Jay Young with Imagine Technologies, and I'll be the moderator for today's webinar. And before we get started, just a couple logistics. We welcome and really would like you to submit questions throughout the presentation. And then at the very end, we'll read those questions. The questions can go into the dashboard on the screen. Just type them in and press send. And then, also this webinar is being recorded and will be posted on the NASFA website under the Learning Series section. With that, let's get started. I'd like to do brief introduction of the three presenters that we have today. Chris Bork is the Building Process Coordinator for the Minnesota Department of Transportation. Chris works as a Building Process Coordinator within the Minnesota DOT Building Services section, with input in the functional and asset management sections. Chris has served as a technical liaison for the research and implementation projects investigating reality capture technologies and their potential for building construction and management purposes. Our second presenter is Joe Eichenseer. He's the Building Solutions Manager for Imagine Technologies. Joe leads a team of Imagine's dedicated services professionals who ensure that the people, technology, and processes exist to providing the best possible solution for clients every time. Joe and his team provide leadership to organizations through the process of selecting, implementing, and optimizing software solutions. They engineer new workflow processes that dramatically improve productivity and efficiency, specializing in the customization, optimization, and integration of Autodesk building design products. Joe helps organizations navigate the road to BIM, Building Information Modeling. His years of experience in the industry make him an able leader in the management of cultural change. And Jay Mizzer is a senior applications expert, reality capture services for Imagine. As a reality capture specialist with expertise in civil engineering, Jay offers a broad industry overview that comes from years of industry experience. His vast experience allows him to help organizations make the most of Leica Geosystems and Autodesk solutions. He understands the workflow from point cloud collection to design presentation and helps teams ensure they're working with the best possible tools for the job. And with that, I'd like to turn it over to Jay to start.
All right. Thanks, Jay. So today I'm going to talk about modeling reality, and I'm going to provide an introduction to reality capture technologies, what a point cloud is, and its applicable uses within the HDS workflow. I'm then going to pass that over to Joe Eichenseer, who's going to talk about BIM point clouds and digital twins, converting the point cloud into a building model, selective data collection, and standards. Joe will then pass over to Chris Bjork, who's going to talk about bringing reality into reality capture, what it's really like to use reality capture on a real project. All right. So modeling reality, how reality capture is changing the world of design. And again, I'm going to speak a little bit about the introduction to reality capture technologies, how they apply to different technologies, and the reality capture workflow, which in my opinion is the most important part to our whole presentation here, is how we use that data. So getting started with an introduction to reality capture technologies, I'm going to jump over and first I want people to understand what reality capture is. right? So reality capture allows the design process to happen in context, meaning you're able to see what's actually out there, not a bunch of just points on a page, right? And we were able to immerse ourselves in the existing surrounding conditions. So then the question becomes, how do we collect this reality data, right? We can get into technologies like 3D laser scanning, aerial LiDAR, mobile LiDAR, photogrammetry, and ground penetrating radar, even sonar mapping off the back of a ship. And, you know, much to my chagrin, yes, even a tape measure, paper, and pencil, okay? So you're able to collect real data with all of these things. It doesn't have to be an expensive piece of equipment. So talking a little more about reality capture, in traditional workflows, we've always used, you know, a traditional piece of survey equipment in some form or another, right? And we've collected points along a project. And we've been doing that for a very long time, whether, again, it's with a paper and pencil or electronic equipment, GPS equipment. But with that, I want you to go ahead and connect the dots here, right? Can you see the bridge? Well, no, not really, right? So that's where we enter the HDS or laser scanning side of things. We can use laser scanning to complete the picture and be able to see the bridges in the real world environment rather than just a bunch of single individual points. So then we're going to discuss what a point cloud is and what I can do with it. Right? So what is a point cloud? Well, it's a collection of possibly millions, billions of points that complete a picture. And as you can see here, as I collect data and the picture grows, the picture is starting to come into focus as to what we're really looking at. Okay? So if we take that a step further and we talk about what a point cloud is, in many instances, a point cloud is our ability to collect a series of individual scans or individual pictures and be able to link that data all together to create a single completed cloud, stitching all of that data together. So then we have to ask the question, what can we do with a point cloud? Where does it add value to our projects? Well, a point cloud provides informed design, right? Our initial design is created in context of all the surrounding areas. So we're able to see whether our new design is clashing with any of the existing elements. We're able to validate that design with as-built data, original as-designed plans, verify retrofits, and any of the changes in that data over time. We're documenting what we're able to do or what we're creating at that moment. So as our design changes, we're able to keep documenting our data. And of course, we're able to monitor facilities and maintain facilities management data with ongoing maintenance and monitor any form of design movement. All right, let's talk a little bit about applicable industry uses. And, you know, this isn't just about the world of high definition scanning. We're also talking about photogrammetry or aerial LiDAR, right? And that data is going to allow us to collect just a massive amount of data over a very short period of time, being able to collect it from high above, again, using photogrammetry or aerial LiDAR. We can use it to collect data in highways and bridges, right? As you can see here, there's several bridges here. Imagine being able to do a virtual bridge inspection without having to hang off the side of the bridge, right? Or be able to measure the size of a beam from below, not having to get up underneath the bridge itself. Okay? We can talk about existing conditions for retrofit. You know, how are we going to take our design and add on, and where does that adding on happen within the existing pieces of equipment that are out there? Okay. We can then take that retrofit and we can put it over top of our existing data and see how well does it fit. We can use things like photogrammetry and site design to ultimately create a point cloud, perform earthwork calculations, being able to measure data around a piece or a mound of gravel or something of that nature, and be able to calculate on a daily basis how much of that material we're using during the course of our construction project. We can use it for construction, observation, and validation. In the image at on the top here, you can see that the beam has slid from its proposed location, and that beam twisted. So what we're able to do is you create a point cloud, scanning this whole beam, bring it into the software, and validate whether that is still a viable piece of equipment that we're going to be able to put in place, or whether it has to be removed and replaced with a new piece of equipment. Construction documentation. In this photo where we're going to go ahead and maybe scan an area, and in the picture on the top, maybe redo some of the molding at the top of the library. Again, construction documentation, where we're looking at an office building and seeing the levelness of this floor. We're able to look at natural rock formations, see how, if any of that rock has fallen or slid, or it poses a danger to the public. And we can do that year after year. We can use reality capture for safety or access limitations, where maybe it's not safe for an individual to enter a space. That data can then be brought back into the computer without anybody ever entering that dangerous environment. Okay. Now we're going to jump in and talk a little bit about the HDS workflow, or a point cloud workflow, and talk a little bit about the basics, right? Creating meaningful data, you're using good workflows. And when we talk about these workflows, we're talking about point clouds and how they can be used in their native format. We can just use a point cloud during the course of a project, never having to do anything else with it other than use it for analysis and measurements, right? Maybe we're never going to model it, or maybe we are going to model it and turn it into solid objects to make it part of our design process. We can use that point cloud data to model into a BIM deliverable. Joe will talk a little bit more about this as we go along here. Okay, we're going to talk about the field work and data collection, data registration, data cleanup, model extraction, and then of course creating a final deliverable. And so as I go along here, our factors of success, and I'm not going to read each one of these lines, but is our ability to use true survey grade hardware where needed. Okay, a dual axis compensator in a scanner provides us the ability to adjust in real time for any scanner movement. Okay, we're using eye-safe laser systems, meaning that, hey, we don't have to wear a special pair of glasses around these things. We're getting range, speed, and accuracy all at the same time. Now, in some cases, we don't need a long range. Some cases, we don't need to be super fast. But all projects have some degree of accuracy that they need to meet. And that's where we go ahead and make sure we're using the right piece of equipment for the job. If that's photogrammetry, it's photogrammetry. If it's HDS scanning, then it's scanning. Our range of target acquisition, we want it within survey control, again, where needed. Our data registration, we want to support traditional survey practices, allowing traversing, resection, other survey methods to automate registration in the office. We have proven accuracy in field target acquisition. Now, here's where things get to be important. We have support for free station scanning, target-based scanning and registration. Or we can automate our free station with targetless registration. Support coincidental extracted model registration, meaning that we can model data and bring it in with our point cloud and compare. And then ultimately, no matter what method we use, we want some sort of report telling us how well our data went together. We can then talk about algorithmic data cleanup, our factors to success. We want the data that we use to be rather clean so that we're not modeling on any kind of object that's appeared through our point cloud. Okay? So we want to work with a single point cloud as a combination of data from all setups. We can do visual segmentation of a point cloud, meaning we can break that point cloud apart when needed and only, in the case of the image at the top there, use part of a building. We can break out the data from the point cloud, whether it's on a planar segmentation, cylindrical segmentation, or undulating surface segmentation. Okay, and then taking that data over to modeling. And that may mean that we're just creating primitive shapes, box, cylinders, spheres, things like that. Or maybe that means we're fitting a model to an object selection in the cloud in our CAD software. Growing object-based and single point selection. In some softwares, we're able to click one point along a pipe and have the software automatically grow a pipe. And then click on the next pipe and grow that pipe. Automatic extraction of shapes throughout a point cloud. Again, we can bring the data into something like Revit and have it build walls, doors, pipes, steel beams, and columns. Automated surface break line extraction. We're talking about a lot of civil projects. And in our civil projects, we can have survey points automatically turned into break lines and take that data over to, again, another CAD package to be able to create surfaces. Or maybe we just create the surfaces within the point cloud software, section it, and get volume capabilities. Okay? And then being able to take that point cloud and extracted model data and have interoperability between the two. Okay? And what that means is we're now taking that point cloud data directly into our CAD system. And we have a data delivery method, having a point cloud that is able to be imported into our CAD software. The weight of the delivered data is hugely important. If we have a very large point cloud and we're trying to bring in billions of points into a CAD system, and the weight of that is so large that the CAD system can't handle it, what's the point? It's not worth using. Right? So we want to make sure that we have the weight of that, and we're using software that makes it possible. Intelligence within the extracted model. If I'm getting just a representation of an object instead of an actual, again, Revit pipe, then that's not gonna be useful to me. I want an intelligent model having become an actual Revit pipe or Revit wall. All right, continued access continued data access during project scope creep, design validation. Okay, and then things that we want to consider when we're working with point cloud data. Our point cloud data management. We want to make sure that that point cloud, again, isn't so large that we can't use it. We want it to be stored in a location where we can get to it and it doesn't make it slow. We want the tool set to streamline the workflow, not have to import and export and reformat data just to make it work within our CAD system. Our data collaboration internally and with project partners. Quite often we have project partners who want to be able to view our point cloud or measure or create notes from our point cloud. But they don't want to buy expensive software to just be able to get that information. So we want to have something in place where they don't need expensive software to view. Okay. Again, proper workflows that allow efficient data use of advanced deliverables, further providing value to the project owner. Okay. I appreciate everyone's time today and me going through this, and now I'm going to pass this over to Joe.
Cool, thank you. And as we're switching between this, that's everything that Jay had there is a great start to everything to be able to say what is a reality capture? What are the types of things that we need to be able to think about? And as we're considering all those things that we need to think about, it goes into the context of, okay, well, what next? And there's probably all sorts of things that each talked about which lead you to next level questions. And that's great. That's part of the purpose of this, is to get to where we're going next. And in this general concept that we've got here, then what's next is the idea of BIM. And BIM gets to be a little bit interesting then, because, I mean, all due love and respect to everything Jay talked about and him as a person and point clouds, and I'm totally bought off on that, but a point cloud isn't COBie data, isn't building parameters. It isn't in and of itself, it isn't a digital twin. It is that geometric data, and that's hugely important as we're trying to get something together to be able to say, how can I develop this digital twin? How can I develop BIM around all of my existing facilities? And I've got now 3D data instead of just 2D data we need to capture, and all these things we need to go with. That it is critically important. It's a key piece in the process, but it's not the end result all on its own. Yeah, there's probably dozens and dozens of different types of spin on the definitions of a digital twin that are out there. This one is what I'm using. It's the digital representation of something that does exist in reality. And if we're going to have that thing that exists in reality, and we need to maybe start attaching sensors to those items so we can get a data stream about that thing. Maybe it's occupancy in a room. Maybe it is flow of material through a piping or ductwork system. All sorts of possibilities of what we could do once we have that digital twin in place. We need to have something sitting there in a model that can act as an anchor point for all of that data, an object that can be linked to an item in a database so that we can start linking that flow of information to a physical thing in our digital twin. If somebody needs to go walk the site to go find that thing from our digital twin, we'll be able to know its location. And if we need to know its location, then again, back to that world of the point cloud. It's all super important through here, but it is just that one piece. If we take a look at that and pull it into the context, in this case, we'll say Revit. Let me switch over here and be able to look at, here's what a point cloud looks like inside that Revit environment. And this is Revit 2020. So it's probably a software that maybe many of you have seen in some form or another. And we can just reiterate and just call this, here is my BIM, here is my model. No matter what software, what thing we're using to interrogate it, here is that model. And this is a series of scans that was at part of a building. To keep things small, I don't have the most powerful computer in the world, going back to one of Jay's points of, you know, how lightweight or heavy is your data going to be. This is what I've got for a point cloud, and it's actual real 3D data. So if I start spinning around, we'll be able to see there's my roofs and other types of things that are going on. I have taken a little bit of time to create some Revit, some BIM geometry here. So I've got an actual wall that's overlaid on top of the point cloud wall. But this conversion process that we have, if we're going from a software agnostic point of view, often gets to a spot of saying that the next step, I've got my point cloud, I can bring it into my BIM environment, but we're largely probably going to be using it as a good way to start tracing things. So for example, if I go to level 1, looking at this same building, let me zoom out a little bit. Here's that same place where I said I drew some walls already, and it was just a matter of having those walls line up with the point cloud. And it can go very, very fast. There's no denying that piece, but it's understanding what's real in here. What are the things we need to pay attention to? If I go to a slightly different view of this, so I can maybe see through the walls, go to a wireframe view, we'll be able to look at different places where, you know, the walls are looking pretty good through here. If I get up to the top of this entryway, you know, call it the lobby of a building or whatever we have, when I'm looking at the point cloud here, it becomes evident that the scan was created from predominantly, in this case, it looks like the inside of the building, because I've got an edge of the wall here, I've got a window ledge, and I've got the outside of the wall. But I'm seeing a lot more information in most of these places just coming from the inside, especially if I'm looking, we'll say over here. But as I'm doing that, this is that place where, you know, the idea of having a point cloud becomes very, very useful to us, because I can see really quickly that the wall does change a little bit. It's not going straight across through here. So if I wanted to draw more of this particular wall type, I can then just, like I said before, come through here and start tracing. Come back over to the side, and just the level of knowledge that's required to work through these types of things is minimal. The amount of training that somebody may need to go through doesn't need to be that much. Let me split this wall here while we're talking. And as we're working through and trying to adjust what's happening in all of these different conditions, it's just a matter of let's get people the knowledge that they need to be able to work with these different objects and generate that building, get that other piece going on. Now, is this not quite the where that wall needs to be because we've got a thicker piece here? Well, then we need to know a little bit more about the software to go ahead and maybe duplicate that wall, make a version of it that's a little bit thicker. Go look at that scan a little bit more closely, or maybe even some pictures that you took while you were scanning, or physical notes to understand what's the reason behind this little jaggedy edge here. Is it actually something that's more artistic or architecturally significant, or is it just where that has crumbled away over time? You need to know what's happening. As we're doing this, we'll very quickly start to understand the difference between the reality of the world that we live in that's captured by something like a point cloud versus the nice and clean world that we wanted it to be. So for example, oops, didn't want to zoom extents. Let's zoom in around some of these columns here. I have placed just a basic round column around these other fluted columns. And as we're looking at them and we start copying these around from place to place, you'll notice that I'm not exactly centered according to the point cloud based off the fluting or whatever else is through there. But the reason for that, let me drop in a dimension here, and this becomes the difference of what do you want to see versus what is reality. This is an exact 2-foot dimension between column to column. And if I get that exact 2-foot dimension, you'll see that this one's a little bit out of place. To get it more accurately positioned, arrow keys or whatever to get it a little bit closer to where it ought to be, and now I've got this 1'11 1/2 dimension. There needs to be a question asked of what is the degree of accuracy that you need for the sake of your model? And that answer can certainly change from building to building, from situation to situation. We need to make sure that you get that information documented so we can work with it, but that becomes a critical part of working with this cloud as we're tracing things, as we're sketching this over, turning it into a model. So now I've got an actual column object that can be the anchor point for data. Now there's something we can work with. If I wanted to come through here and drop in an asset, in this case, we'll look at a table. That's where it was at before. So we'll just go here and say I'm going to place in a component. It's going to be a table. This table, let me zoom in a little bit so we can see it better, but it's not the same size. It's a little bit off. So again, this is a place where I probably need it to be more accurate. So as we drop back in, this is one way through a piece of software where I can say, let's duplicate this and call it a 48-inch table. I'm assuming that's right. It looked about right to me. Could also take a dimension across that, just doing a dimension across the point cloud. And then, yeah, that's closer. It's probably a little bit overkill, so it might be somewhere in the middle. Or according to this, maybe that table is actually a little bit oval. If we look at my circle, it's fine edge to edge, largely, but top to bottom is very different. So gives us that extra thing of, do I need to really care that that table's not a perfect circle? I'll argue probably not. What's going to be more important is the data in that circle, in that table. So I'm looking at the table here. If I look at all of its different properties, whether we're talking about it being COBie or other parameter types that you care about more based off of, you know, databases or things that you've got fixed into it, fill in the appropriate data, because this is where that digital twin really starts coming to life. The geometry is a critical piece. We need that geometry as an anchor point for everything else that we'll do. But once it's there, now we got to start talking about data and use this as a tracing point to get a very good, very accurate model of our existing facilities, but then turn around and start working in the data sense so that we can start making those linkages. When we do that, we'll turn back around and then make the conversation, well, what data? If you look at COBie, if we look at all the possibilities of data formats and things that are out there, from our side, we've been producing, you know, different types of models for our customers in any number of different ways, but we always have to ask these different questions in one form or another. And we've been promoting these questions for a long time too. Just what do you think you need? Once you've got that, who's going to collect it and how are you going to keep it up to date? If you can't answer one of these questions, you've got to kind of start over and think again. There was a customer of ours that I'll leave nameless, but they had their facility and the general contractor came to them and says, hey, we're doing this as a BIM deliverable. What data do you want? Well, separate from that meeting, that customer came to us and said, hey, we can get a BIM. What data do we want? I can't answer. Make sure you've got a standard behind it. If we're talking about data, this is just a clip from a Tennessee standard, so the link down there below if you wanted to look at it. You don't need to recreate the wheel. Use a standard that exists out there. Just find somebody that's similar. Maybe state of Tennessee won't be that for you. Maybe it could be. Maybe you want to go and take a look at another university. There's all sorts of possibilities that are out there, but have a standard and stick with it so that if you're looking at the something simple like the naming or the data convention for a room ID number, to make sure that everybody's putting it in the exact same way and it becomes a consistent, reliable piece of data that we can work with. But it has to be based off of a standard. So when we're looking at things, start small. Take an idea saying, here's a simple, not your architecturally significant building on your campus, but a simple building. Get it converted over to a model, identify what your data standards need to be relative to that model, figure out if you were correct or incorrect on any of the things that you thought you were going to be bringing into place, and then reevaluate. Is this something that we can turn around and repeat across our entire campus? Or based off of what we really got out of that BIM, what more can we do? What more or less should we do based off the reality of workforce, of looking through and mapping those different key fields to understand what is the function that we need to have our data support for us, but have that standard process, get it through a small call it a pilot project if you need to. Identify where you can expand on what you've done or contract from what you've done, because that was actually a lot bigger than we thought it was going to be, whatever might happen to be the case. And then get the data out there, whether we're talking about COBie and getting that information into a COBie formatted spreadsheet, if you're talking about getting this information and tying it into barcodes or QR codes, get that information to a place so that we can start tying it through databases based off of object IDs, unique identifiers, all those things. The point cloud becomes the first critical step, or more to the point, reality capture, because as Jay mentioned, tape, measure, and pencil can work too. That reality capture piece, which maybe it involves a point cloud or photogrammetry, is the first step in getting things together so that we can then convert it inside your BIM platform and then start anchoring data. So that's the overall process of the things that we're looking at. When we want to go a little bit further into those next steps, what I'd like to do here is turn it over to Chris to talk about his specific situation and where they took this. So Chris, over to you.
Yeah, thanks, Joe. Okay, if you want to hit the next slide. Yes, so as an employee at the Minnesota Department of Transportation in the building services section, we were kind of tasked with the issue of identifying what these technologies are and how can we implement them into building services, because we're kind of starting on a blank slate. The amount of LiDAR scanning isn't something that we were using, and the technologies were all new. So in order for us as a division and an agency to go about researching this, we created TRS, Transportation Research Synthesis, in which we hired on a consultant and we explored all the various technologies that mainly have been talked about already, but with the LiDAR scanning, drones, 360 imaging, photogrammetry. So moving from there, we went through the project, started identifying all these new modalities. So if you could hit the next slide for me. At the end of our report, our consultant with us went through, developed questionnaires, reached out to other agencies, seeing what they were using currently for things like as-built and any other technologies, and what the roadblocks were to them to implementing that. So if you could hit the next slide. Some of the lessons learned was that there was an overwhelming amount of technologies out there, but trying to find which one fits our situation the best was still up in the air. So after we had kind of identified all these modalities, the next steps that we had to exploring it was to set up implementation project. Do you hit the next slide, please? So right now where we are is kicking off July 1st. We're going to extend our project into a transportation research implementation project where we've teamed up with the same consultant. And now that we've identified these technologies for building usage, now we're going to go in and start exploring them and seeing what kind of deliverable these technologies will provide. The overwhelming and overarching kind of comment that we get from point clouds is that while it's incredibly neat, what's really useful for us? So just identifying what technologies can provide us the best deliverable when it's all said and done is what we're looking at now. So that is where we stand with our research into 360 scanning and reality modeling. We'll go to the next slide.
And that opens us up into the Q&A section. We certainly wanted to try and make sure we had some good time left over for this to try and handle all the different types of targeted and specific questions that everybody had for any of us that were here speaking, Chris on his practical research and application, or myself or Jay.
So with that, there's still time to type in your questions in the question box on the dashboard, and make sure you hit the send key. There are a few questions which we'll start getting into and answer a few of those now. And I'm not sure if which one of you guys wants to handle this, but there were a couple questions regarding, you mentioned COBie and the Construction Operations Building Information Exchange. Maybe discuss a little bit about that and some practical benefits of COBie.
Sure, this will be Joe talking about that, and just from at least taking first stab at it. The idea with COBie is it's a data standard, and it's a documented, identified, defined, whatever other adjective you want to go through there, data standard that anybody can utilize. And the idea behind it is because it's a national, global data standard, any number of different applications can then start turning around and working with it. So if you've got a facilities management or an asset management system, I would be surprised. I would expect that any of those systems would be able to read in data that's been formatted according to COBie. So the idea behind it is let's just do what we can to make sure that data is transferable between different systems. So if we input data into a COBie or can export it to a COBie format, we can take it somewhere else and let data flow instead of being locked up in a certain proprietary place. So that's the idea. That's the point behind it. Do you have to use COBie? No, absolutely not. Do you have to use all of COBie? Heck no. There's too much in there, in my opinion. So this is just one person's opinion. The COBie data standard is all sorts of things to all sorts of people, but you'll use a fraction of it. So identify the fraction of it that works for you, and then use it as a way to share data, to work with things back and forth.
Oh, great, Joe. Thank you. We'll stay on the COBie theme for just a second. There's another question. Can COBie be integrated with GIS, or is it a separate entity that GIS can use?
I would say that COBie could be data that is associated to aspects of GIS. And I don't know if, Chris, you'll have something to add to this as well or not, where your experiences there is, but GIS being geographic information systems, if I'm not getting the G word wrong, we'd be able to say, here's where all my buildings are. And you might have COBie data attached to the building that has information about owner or address or things like that, key points of contact. So there can be something in there, but I would say there's some level of overlap, but it's not perhaps as deep as you might be once you get inside a building. And certainly indoor GIS gets to pull that open as another set of range of possibilities.
Okay, great. Well, something just moved. Okay, if we want to have engineering analysis capability from our model, what level of LOD, level of detail, is needed in our Revit model? Or less a general question.
Yeah, what level LOD is needed to allow engineering analysis?
Correct.
Loaded question, because it all depends on what analysis are you looking for. I can be at LOD 100, level of development 100, which is conceptual models, massing models, and take that into different systems to be able to say, well, in general, based off of where my building is at and what's happening here, let's do some conceptual building analysis of what's the likely heating and cooling load cost and energy requirement carbon footprint of the building based off of some assumed construction methods. So even at LOD 100, you can get that. Now, that being said, I'll have an assumption here that you're talking about a more finite level of analysis of doing maybe room-based error changes per hour calculations and what's really happening here, there, wherever. For that type of thing, you're really, again, the higher LOD you get, up until we'll say 350 or 400, you're getting more and more finite analysis possible. Because if you're at LOD 300, we'll say, you've got something saying, well, we've got a 20-ton rooftop unit, but it's not necessarily a specific manufacturer. But can I do more accurate building heating and cooling analysis, knowing that this is the spec for my HVAC units, as opposed to what I was doing when I was at LOD 100 and doing conceptual? Yes. Can I get even more detailed if I have a specific manufacturer model sitting somewhere for that analysis? Absolutely. So the answer is a big old variable. It depends on the type of analysis that you're talking about. If you need to get at something that's highly accurate, then you're looking at LOD 400, getting that manufacturer specific information in there. Most of the time, though, when we're looking at, in my opinion, so again, Joe's opinion, we're going to be able to get perfectly sufficient analysis, even at an LOD 250 to 350, depending on what you're looking to get out of that. So it's all dependent on how detailed does your analysis need to be. As your analysis needs to be more detailed, your LOD requirements also go up.
Great, thanks, Joe. Chris, I think this question is for you. Understanding that perhaps the scope is still being developed, what does MnDOT desire to capture, and how will the data be made available to the users?
Well, right off the bat, some of the first pieces of information that we want to be able to capture are as-built drawings on some of our buildings. If you realize that some of our buildings go back to the 1920s when they were built, the loss of information just over time has occurred. So we may not have drawings on these existing buildings. We may have never even received the drawings back then. So much time's passed. So for us to be able to go out into the field and then using a tool like an indoor scanner, like a GeoSlam, go and take that LiDAR scan of the building and then come up with our drawings, so we know what we have for space and there in the building. That's one of the first low-hanging fruit, I think, that we're getting. But then we're also looking a lot from asset management perspective. So if we can go and scan these sites and start getting quantities of data for further condition assessments, just recording of what we have on these sites is going to be big as well. And we've already got projects going on with GIS mapping of our sites, but now we're looking at how can we integrate more data into that. Are we capable of linking a LiDAR scan to these GIS coordinates that we have on site? So those are some of the things that we're looking at the moment. I hope that answers the question.
Yeah, and will those be made available to the users? I'm not exactly sure who the users would be doing the design work.
Yeah, the users would be direct customers within our office at the moment, but we do use some facility management software, an Archibus, that some of this data may be stored in. We do have an Esri GIS mapping that's being stored online, that some of this information can be accessed through, hopefully in the future.
Okay, here's a good question. Probably for Jay. Chris, you may have done some evaluation on this too, but question is regarding scanners. Knowing that it's an evolving technology, and things are changing. How does that technology differ in pros and cons between like a handheld scanner that you carry versus like a tripod mounted system, or even like a backpack type of format for a scanner?
Sure. With this is Jay, by the way. With any scanner, one of the things we're always kind of talking about and going from one to the other is features, just almost like with anything you buy. And you mentioned a handheld scanner kind of versus a tripod scanner, and I'll go with that comparison. So when we look at a handheld scanner, we are gaining just being able to collect data very quickly. But one of the things we lose with that handheld scanner is the ability to collect data very accurately. So if you're in an environment where, you know, something within an inch is good enough accuracy for you, a handheld scanner is fantastic. If you need more accuracy than that, to fractions of an inch, that's when we move to a tripod scanner. And we use the tripod scanner, we'll get a much better accuracy than we would necessarily with a handheld. And then, of course, within the tripod scanners, there are different features and functions that are possible.
Okay, and Jay, when you're talking about a handheld scanner, not one that you're taking a scan of something on a desktop, but you're talking about like walking down a hallway at a normal pace, right?
Exactly. Usually a little bit slower than normal, but yes, you are walking down the hallway with this thing held out in front of you, and it is picking up imagery as well as point cloud data. And again, it's you know, the more you focus on a specific area, the more data it's going to collect, but the level of accuracy isn't as high as a tripod scanner.
Okay, but you could cover like a whole building in a relatively short amount of time.
Correct.
Relatively. Okay. Here's a question, I think a very specific question to scanning in the Washington, D.C. metropolitan area. Do you know of any good-sized building or facility in that area which has used a Revit model successfully?
Yes. Oh, geez, I forget. It was one of the larger train stations, and I can't for the life of me remember which one in the DC area. I don't live in DC. But yes, one of the larger train stations where it was completely scanned and a Revit model was created.
Yeah, much like the Air Force Academy, isn't it? Where didn't they do that whole big assembly?
I don't know that, to be honest.
Okay. Several questions about do you use BIM 360 docs? And what other BIM 360 modules do you use? Does Kobe integrate with BIM 360?
This is Joe. I'll grab that. I would say that the Kobe data standard is really independent of BIM 360 or any of your other file storage, file transfer, collaboration sites. The BIM 360 world is one vendor's way of allowing multiple people to work on the same files at the same time. So you have a single source of truth. Everything's all in one place. You get to share, you get to control. It's all sorts of wonderful whiz-bang things. But it's, while you can have access, you can see data in some of your different types of files. You can mark up and do whatever. In and of itself, it has nothing to do with Kobe. You could have non-Kobe standard data points and still be able to do all the same things. so that they're relatively independent of each other. You can use them together, absolutely. You can have a model with all the right data standards and compliance inside there, and going through that full process, 100%. And that could work with, again, that Autodesk BIM 360 world, or any vendor file sharing program, Box, Dropbox, ShareFile, you name it, because the data standard is what's happening inside the file. It's not what's happening on that hosting platform.
Very good. This is probably going to be one of our last questions, and more about scanning itself. So either Chris or Jay, but about the scanner, is it able to scan underground manholes, trenches, you know, and I would add, you know, in dark areas, maybe even up in ceilings.
Yeah, I'd be happy to take this one. This is Jay again. The scanners all depend on which scanner you pick, of course, but most of them nowadays are able to go ahead and be flipped sideways, upside down. So yes, quite often you can flip it upside down, put it in a manhole, be able to scan the manhole, and then be able to bring that data into the computer and have it be upright. So yes, and then you asked also about dark places, whether it be you know, above a ceiling or in a very dark room. Absolutely, we can scan in complete darkness. The only thing that will not come out correctly is obviously pictures. We won't be able to take good pictures with that very dark room or black room. But again, even some of the newer scanners with very low light, they take HDR imagery, which allows you to turn up or turn down the light.
Okay, great. Well, guys, I'll tell you what, we're at the top of the hour, and we want to respect everyone's time. And thank you for presenting, Chris, Jay, and Joe. And I'd like to thank all the people for being part of this and attending the presentation as well. In June, NASFA is going to have the next in our learning series, and that will be available on the NASFA website, as well as we'd like to encourage any state or department or agency, somebody with a project, to get involved, and we're looking for suggestions for another webinar that you might want to do. And you can just go to NASFA or send an email to nasfa@csg.org, or go to the NASFA website, nasfa.net, and submit any suggestion you might have there. Over the next couple of days, we're going to put a recording of this webinar on the NASFA website under the Learning Series. And that concludes our webinar. I'd like to thank you all for attending, and please be safe. Take care.